Let's look here on weak bases. I hope you've already watched the video on weak acids. This will be a bit shorter because I'll presume the information we covered there you've already learned. And it's pretty symmetrical. In terms of weak bases, your most common weak base is going to be ammonia. The analogs, the organic analogs of ammonia, which are going to have a nitrogen attached to them. Here we've got CH3 methylamine with an NH2. The reason the NH2 and the ammonia acts as a base is because it's got this pair of electrons. And this pair of electrons is going to be attractive to an H+, and it'll stick onto there and will accept a proton. The other types of weak bases which are used commonly are the conjugate bases, I should say, of weak acids. And for that, you're going to have the anion of the weak acid, the A-, stuck together with a sodium or potassium. So these materials will end up breaking apart, dissolving, because sodiums are all soluble, to make sodium ions and acetate ions, and these acetate ions will be picking up H+. So there's two sort of versions of our bases acting, where we've got a neutral base like ammonia getting a hydrogen from water and becoming Hb+. And then we have our hydroxide floating around in the water, which is going to produce our alkaline situation, our basic situation. Or if we have the conjugate base of a weak acid, an A-, doing the same thing to the water, picking up its hydrogen again to become the original weak acid and producing OH-. In either case, we're going to have our hydroxide ion and what other conjugate was with it, with the original amount of our base here. In fact, actually, I've got an error there. I should just write this one as B. Now it's going to end up being right. And everything that we've learned about in terms of weak acids and their Kas works with the Kbs. The only thing is that you will instead be calculating the hydroxide ion concentration using the same general formula, square root, and for the same reason, because of these two substances being equal. The Kb times the concentration of the base will give you the hydroxide ion concentration. Once you've got the hydroxide, negative log gives you the POH. Once you've got the POH, 14 minus POH will give you the pH. And generally people will want to know what the pH is. So you've got an extra step where you convert a POH into a pH. But still it's the same general formula. Just realize that when you're using it, you're finding the hydroxide ion concentration rather than the hydrogen ion concentration. All right, that's it. That's weak bases.